Hi everyone, in this video we're going to go over completing the square just a little bit. You've seen some previous videos about how that process works, and then how this relates to the vertex form of a quadratic equation. So starting off, and again this is from our handbook, so this is going to be pages 41 and 42. For this first example, we have y equals x squared minus 10x. So there's no constant term in the back here, there's no third value. It's normally a number, so plus some number like these other examples. So this one's a little easier. And every time you're completing the square, you take half of this coefficient on x and square it. So we're going to take half of negative 10 and square it. So that's going to be negative 5 squared, which is 25. Okay? And then we can't really change the equation, so what we do to account for that is we take away whatever we add. If we're going to add 25, if we take it away, it's going to get us back to where we started. Okay, but we added it for a reason. We added it so that we can factor this trinomial, 3 terms, 1, 2, 3, very nicely. The extra 25 that we took away in the back here, it's just to account for our original equation. And so this trinomial here, when you complete the square, the whole point of it is that it becomes something squared. You're completing something that was not a perfect square, now it is, and it factors very nicely. It factors as the same factor times itself, and from factoring we know what this one is going to factor as. This is going to factor as x minus 5 times x minus 5. And you can FOIL it out and you'll get back to exactly here. Now there is kind of a shortcut that's nice to know. Anytime you're completing the square, if you go right back to this step up here, so let me label it in a different color. So right back to the original step, when you took half of this value in front of x, we call this b normally. It's ax squared plus bx plus c. So half of that value, right before you squared it, that number, it's not a coincidence, is always going to go right into your factors. So that's kind of a nice shortcut. This one, it's not hard to factor. We could figure out that it's x minus 5 times itself. But sometimes when it's harder, it might be nice to look back here and say, oh, that negative 5 is going to go right into my factors. So a nice shortcut for us. And so x minus 5 times itself is x minus 5 squared. And then there's still that minus 25 in the back. Okay. So this is considered vertex form of a quadratic equation, because when it looks like this, you can tell really quickly what the vertex is. The vertex being that center point of a parabola. The vertex is always going to be the number after the minus sign here, and then the number in the back. So the vertex is a point on your graph, and it's like the center point. It's not negative 5, it's actually positive 5, comma 25. It's the number after the minus sign. Okay, so let me just kind of make this very clear. In general, it looks like negative x minus h. It looks like a negative, but it's really not. It's the number after the minus sign plus k. And then the vertex in general is h comma k. So it's the point h comma k, where h comes after the minus sign. Okay. The axis of symmetry is going to be the line that goes right through the middle of the graph, so right through this vertex, and it's always just this x value. So it's always just going to be x equals whatever number we have there, so in this case 5. And so we can graph this pretty quickly just by knowing the vertex. And so I need to be able to get this point on the graph, so I'm just going to do a rough sketch. It doesn't have to be that great. And so let's see, I'm going to just give myself enough space to go over 5 and up 25. I'm kind of just estimating here. This is 5, this is 25, and so the vertex would be right there. And then this parabola, it has a positive x squared, so it's going to open up. And I'm just doing a rough sketch, but it's going to go up and over 1 to the right, up and over 1 to the left, and it's going to look like this. Okay, so not a perfect sketch, but an idea for what this looks like. Okay, let's try the next one. Y equals x squared plus 6x plus 2. So half of this coefficient on x, half of this b term, we call that b, remember, because I was saying ax squared plus bx plus c. So half of b, or half of the coefficient on x, squared. So it's always that half of that number squared. So that's 3 squared, which is 9. So we're going to add, but then also take away 9. Notice the plus 2 that was already in our equation, we kind of just scoot it over to the back, okay? Because what we're trying to get to is right here. We want the 3 beginning terms to make a perfect square trinomial. So we have x squared plus 6x plus 9. We want to focus on that. And so all the other numbers, the constant that was already there gets moved to the back, and the minus 9 gets moved all to kind of to the back as well. Because remember, the minus 9 is just there because we have to account for how we changed the way this looks. If I remove this, if I say plus 9 minus 9, I get back to where I started. So this is just to keep us having the same equation we already had. We're just kind of making it look different, but it's still equal to the original. And so in the back here, we have a minus 7, because minus 9 plus 2. And so the vertex form, we are going to factor this trinomial. And so if you just look at this one, you can tell by looking, some of these you can factor just by looking at them. I need numbers that are going to multiply to 9 and add to 6. And then I can take that shortcut because there's an invisible 1 in the front. This one factors really fast if I know that it's just x plus 3 times x plus 3. And then if you remember what I said about my shortcut a minute ago, if you look back here, 3 was this number before we squared when we took half of 6. So that's the shortcut. That's always going to go into the factors. So then you can write it as x plus 3 quantity squared minus 7. So then the vertex, I'll just abbreviate, is always this number after a minus sign though, comma this number. So let me make sure that you see this one, because the last one was a little different. You have to account for this as if it had a minus sign. And so this is really minus what? What would I put in this space right here if I wanted it to equal positive 3? So I would say minus negative 3. So there's actually going to be a negative 3 comma in the back, negative 7 for the vertex. The shortcut on that is whatever it looks like in the parentheses, just write the opposite as your vertex. So if it looks like plus 3, write minus 3. On the last example, it looked like minus 5, and we wrote positive 5. So that's kind of the fast way to do it. And then our axis of symmetry is just the line going through this x value, so x equals negative 3. And so we'll quickly graph this one. This one's going to open up also because it had a positive x squared term. So we have just a quick rough sketch of this graph. We're going to go to negative 3 and then down 1, 2, 3, 4, 5, 6, 7. And then this parabola would open up. Okay. I should have slightly more accurate points, but in another lesson you'll graph more accurately. I'll just have that kind of roughly there. This is not quite wide enough, but you'll see when we do the next pages in the handbook that you'll get some actual points here. Now, this axis of symmetry, let me just graph it for us really quick. It's the line that goes right through the middle vertically. So that's the axis of symmetry. X equals negative 3. Over here, it was a line that goes right through the middle. It's like where I would put a mirror. If I had a mirror and my graph could be the same on the left and right, that's the mirror line, axis of symmetry. Okay, next one. 2x squared minus 20x plus 47. This one's a little trickier because you have to factor out any number in front of x squared if it was not 1, okay? So we can't take half of the coefficient on x yet. We have to factor first. So I'm skipping the step we were starting with on the previous two examples. I can't take half of negative 20. I would get the wrong value. I have to factor out this 2 first. This 2 is an issue. I have to factor that 2 out first. And I take it from all the terms. Well, actually, the 47 we're just going to bring to the back. So I'll take it from the first 2 terms. So if I divide 2x squared by 2, I get x squared. If I divide negative 20x by 2, I get negative 10x. So right here is where I'm going to take half of this coefficient on x. So half of negative 10 squared. So that's negative 5 squared, which is 25. So we are adding and subtracting 25. Excuse me. Now, here's where it gets kind of interesting. Because we had to factor out this 2, it's going to affect our minus 25, and here's why. We have x squared minus 10x plus 25, and I want to close the parentheses there because I only want this perfect square trinomial to be in the parentheses because that's what I'm going to factor. So if I do that, then I have to think about, well, what number happens here if I bring this 2 all the way over to multiply by the negative 25. So what I really have here is, because I took this negative 25 out of the parenthesis, I have to put the 2 with it because it was really 2 times this negative 25. So that's really a minus 50 because I had to say 2 times negative 25 and then plus 47. Okay, so that one you have to be a little careful about. Anytime you factor out a coefficient on x squared, you have to do this extra piece where you make sure you take that number, multiply it by this value you subtracted. Okay, and so now our perfect square trinomial factors really nice. We already seen this one earlier. This was x minus 5 times itself. Okay, so our vertex form is y equals 2 times x minus 5 squared, quantity squared, and then in the back, minus 50 plus 47 is minus 3. And so our vertex here, in the parentheses, x minus 5, the x-coordinate of our vertex is positive 5, and then the y value is minus 3. Okay? So again, it's always the number after the minus sign when it comes to this x minus the number, the part inside the parentheses squared. Okay, so it looks like negative 5, but we write positive 5. If it makes more sense, really what we're picking is the number that would make this 0. So positive 5 would make this 0. If you go back to the other examples, negative 3 would make this quantity 0. Positive 5 would make that quantity 0. Now when we graph this, it's going to just be slightly affected by how the shape of the graph looks because there was that times 2. The axis of symmetry is this x number, so x equals 5. It's the line going vertically through 5. But when we graph it, let's see, we have our vertex. We're going to go to positive 5, 1, 2, 3, 4, 5, down 3. I'm just doing really rough, quick graphs. We can graph more accurately in the future, but what I'm emphasizing here is how to get the vertex and put this equation in vertex form. So what I was mentioning is, because there's this times 2 in front of our function here, you are multiplying your parabola, you are multiplying the outputs by a factor of 2. Okay? Now, if you remember from transformations of graphs that we talked about a while back, if you multiply by a number bigger than 1, it's actually going to stretch your graph vertically, so it's going to look thinner. So this graph, and this is just a quick sketch, it's going to look thinner than a normal parabola. Okay, so this one, I kind of drew this one a little wrong. I feel like it should have been way wider. It was a really quick sketch back there. But this one should look thinner, stretched vertically. Okay, let's do the next page. Okay, page 42. We're going to do 3 more, and 2 of them are very generalized. So this next one, we do have to factor out this negative 1 because we don't want to complete the square. We can't actually do it correctly if there's any number in front of x squared. Any number that we can see, basically, any number other than 1. And so what I'm going to make sure that you see is that this negative 6, this minus 6 as the last term, that's okay. We're not focused on that. We're focused on the terms with the x in them. And so if I factor out a negative 1, negative x squared divided by negative 1 is x squared. Plus 6x divided by negative 1 is minus 6x. Okay? And then for the completing the square process, we are going to add and then take away. I didn't give myself very much room, but take away the same value, the same number. So here's where we get that number. We take half of the coefficient on x and we square it. Okay, so half of negative 6 squared. So negative 3 squared, which is 9. So we are going to add 9, but then we have to take away 9 just to make sure that we keep our equation the same. If you add 9 and take away 9, it's back where you started. So we're just changing the way this equation looks. Now, like the last example, let's account for this minus 1. I only want the first 3 terms in here to be in my parentheses because that's what I'm going to factor. So x squared minus 6x plus 9. I want to take that minus 9 out, but I have to be careful. So we talked about this just a moment ago. If I take this minus 9 out of the parenthesis, I have to bring this negative 1 with it because it's negative 1 times this. So negative 1 times negative 9, I'm actually taking out a positive 9. Okay, and then this perfect square trinomial, these 3 terms, factor as x minus 3 times x minus 3. And again, the shortcut, I mean, this one we know, we can factor that one quickly, but if we didn't know, we could look right back here. Here's negative 3 before we squared. Those numbers go right into our factors, okay? And so this becomes, and I'm going to leave off the 1 here. I'm just going to put the minus sign because that's what we tend to do. Minus x minus 3 quantity squared plus, in the back here, 9 minus 6 plus 3. Okay, and so our vertex is this number after the minus sign, so 3, comma, and the number in the back, 3. And then the axis of symmetry is just x equals this x value. Okay, so let's graph this one. We have 3, comma, 3 as our vertex. And now this parabola, it had a minus in the front. So that flips the graph vertically. So this graph would be a parabola flipped downward. Okay, just a really quick rough sketch, but it would look something like that with the axis of symmetry right there at 3. So now let's generalize this. When there's a coefficient of 1 in front of x squared and when there's a coefficient other than 1 in front of x squared. Okay, so when it's 1, we get to skip the step of factoring out like we did in the last, I think we had to in the last example. And so we just start right here. We say half of b, half of this coefficient on x squared. Okay, and so we can't do much there other than say b squared over 4. We can leave it as b over 2 squared or just say b squared over 4. And so that's what we're adding and taking away. So x squared plus bx plus b, I'm just going to leave it as the factored one, not the squared version. So b over 2 squared and then minus that same quantity, b over 2 squared, and then plus the c that was already there. So I add something, but I take that something back away. And then these first terms, okay, so let me just put in this next step. The first 3 terms are a perfect square trinomial. And so this is b over 2 quantity squared. And in the back, now I'm going to go ahead and just say that that's minus b squared over 4 plus c. And so this factors, same process we've been doing, and this is where the shortcut could come in handy for you. You would say, well, what numbers multiply to make b over 2 squared, but then add to make b, and it's b over 2. And we've talked about this a few times, so the shortcut for figuring out what goes in the factors is right here. Right before you square half of b, that value, whatever it is, goes right into your factors. And so we have y equals x plus b over 2 quantity squared, and then just this minus b squared over 4 plus c in the back. And so in this case, the vertex would be minus b over 2, because remember, if it looks like plus a number, you take the opposite, because you're really saying, if this was a minus sign here, minus what? So minus negative b over 2 is what we would take from here. Okay, that's this part here. And then in the back, all of this is the y value. So negative b over 2, sorry, negative b squared over 4 plus c. Okay, and I'm not going to graph this because they're not actual numbers. So then to generalize it here, if there is a coefficient in front of x squared other than 1, we have to factor that out first. So I can't take half of b yet. Anytime there's a number in front of x squared other than 1, I have to do the factoring first. So that becomes x squared, and then if I divide out an a, there's no a in bx, so here's where we get a little algebraic over here. I have to divide out an a, so it's really going to look like b over a times x, okay? And then I'm going to just do it in the next step. So the plus c is still in the back, and then what we do is we are going to add and subtract half of the middle term, this middle coefficient right here. So I have x squared plus b over a x plus, and then minus something, and then the plus c was in the back. Okay, so I am taking half of the coefficient on x after I've taken out the a, after I've factored out a. So half, so I'm back to like this step on the previous example, but we had to factor out the a first to get there. So half of, let me write it here, half of b over a, so half of that, okay, I'm just going to say times 1/2 squared. Okay, so that's going to be b squared over, actually let's do it in 2 steps. B over 2a quantity squared, which is, I might be running out of room here, okay, which is b squared over 4a squared. Okay, a little tricky looking, but that's okay. B squared over 4a squared. We add it, but we take it back away. Okay, now we're only going to focus on the first 3 terms because that's what makes the perfect square trinomial that we can factor. So it's a times x squared plus b over a x plus b squared over 4a squared, and then I'm going to take out this other term back here, so I still have my plus c, but this is the part where I take the a and I'm just going to write it underneath. Because I'm going to take this term out of my parenthesis, I'm going to multiply by this a in the front. So a times a fraction where we're dividing by a squared, so a times a fraction where a squared's on bottom, this a is going to divide with one of the a's on bottom. So it's going to look like still b squared on top, but one of the a's on bottom, that was a squared, divides with this a that's going to be on top. So minus 4a. Okay, almost there. This one's going to factor as x, and now real quick, going back here, it's going to factor as this right before we squared. So it's going to factor as x plus b over 2a times itself. Okay, and so we have y equals a times x plus b over 2a quantity squared, and then in the back I'm going to do something a little different this time because I want to show you where this is headed. I'm going to go ahead and times the c so that I have the common denominator with the negative b squared term. So I'm going to times this by 4a over itself, so times by 4a. So in the back here we have minus 4a is the denominator, b squared plus 4 times a times c. Okay, so I'm not going to focus on the vertex. This is good enough. I just wanted to show you something. The whole point of this one, and I know it got kind of really algebraic on these last 2 examples, but don't worry too much about them. But this one, if you've ever seen the quadratic formula, this is where it comes from, okay? If you know about the quadratic formula, it's looking like we have that here, okay? If we were to, and we'll get into that in the future, but if you recall, if you've ever heard of it, you have, I'll write it right here. So for a quadratic formula, you have negative b plus and minus square root b squared minus 4ac all over 2a. So it comes from solving this equation. Okay, so we won't do that now. I won't like solve this, but I just wanted you to see in general. So don't worry too much about these last two. It's just sort of generalized for you what's happening with these quadratic equations. But you do just want to make sure a couple of things. If there's ever a number in front of x squared, you have to factor that out first. Then after that, you always take the coefficient on x, you always take half of that. Okay, half of that, and you square it. And that's how you complete the square. You take half of that and you square it, you complete the square, and then you factor. Okay, that's it.